Welcome to qnawire.
Okay, so the question is asking us to determine the wavelength of the second source. So what's known here? We know the spatial separation of the first order wideband from the first source is 0.28 meters, and the wavelength from the first source of light is 630 nanometers, and the spatial separation of the first order wideband from the second source is 0.20 meters. So it's asking us to figure out lambda 2, which is the wavelength from the second source. How can we do it? First, we know there's a formula. Look like this, and that's for the spatial separation, which is, let's see, sorry, which is ym equal to m lambda l divided by d. M here is the order, lambda here is the wavelength, L here is the distance between the grating and the screen, and D here is the separation between slits. So we don't know L and D here, that's fine, but we know M here, which is 1, because it says first order, so M is equal to 1, okay? Lambda is given 630 nanometers, so we can just leave L over D as a whole on the either left side or right side. I will show you specifically what I mean during the calculation. So let's take a look. Okay, so you give us this equation will give us y1, which is given equal to 1 times 630 times 10 to the negative 9 meters. Is because 1 nanometers is 10 to the power of negative 9 meters, and then times L, we don't know, and D. And we know that y1 is equal to 0.28 meter. So L over D would just be y1, which is 0.28 meter, divided by 1 times 630 times 10 to the power of negative 9 meter. And that will give us, let's see, about something like this. It's a bunch of 4. It's a 6 digit of 4. Okay? And so we know L of D here. And okay, so L over D is equal to 4, 4, 4, 4, 4. Okay, y2 is equal to 0.20 meter. So the y2 here doesn't mean the second order. The reason why I put 2 here is because I try to distinguish the y2 from y1 because they are from 2 different sources. And you understand what I mean if you take a look at the question. So, okay, we need trying to figure out lambda 2. And we already know the equation from the previous one, which is ym equal to m lambda L divided by D. So in this case, we need to figure out lambda 2, which is the wavelength for the second source. So, well, you know what, I will just write it down, the equation again, just to make sure you guys can see it. Okay, so y2 is known, m is known, m is 1 as well, since we're only talking about the difference between 2 sources. So the order of the band is the same. Okay, and L over D is known because the same grating and same screen. and the second separation of a slit. So this is what we got, which is y2 m lambda 2 L over D. Okay. So therefore, lambda 2 can be equal to y2 times D divided by m over L. Okay. And remember, we can always separate it since it's a dot product, which means it's multiplication. And D over L is just L over D, the reciprocal of the L over D, like this. So they will give us, okay, y2 is 0.20 meter, okay, m is 1, and the reciprocal of L over D just reciprocal of such digits. So eventually, lambda 2 will equal 4.5 times 10 to the negative 7 meter, which is 450 nanometers. It's because 1 meter is equal to 10 to the power of 9 nanometers. Okay, so that's my answer for this question. Thank you.